Understanding proportional factors. First, a crash course in IBP disaggregation. An IBP key figure can be disaggregated three major ways. Copy, a value entered at a higher level will have that same value copied to the lower level. A good example would be a price key figure, where you would want to enter a price at a higher level and have that same price copied to the lower level. Equal. A value entered at a higher level will have that same value equally distributed to the lower levels. Not sure there's a good example, but it's pretty much the last IBP option if there's no data populated in the key figure. Proportional. A value entered at a higher level will have that same value proportionally distributed to the lowest level. 99% of IBP key figures are disaggregated this way. The challenge is making sure the proportions are correct. Second, let's talk about why this is important. A statistical forecast is typically executed at a product location level. But the data is stored at the product location customer ship to level. And there are a lot of attributes that need to know the customer. So if you want your other aggregations to be accurate, you need to make sure your disaggregations are accurate. Another example. Let's say you forecast at the product location level. Here we have a consistent demand of 600 every month. Not surprisingly, the statistical forecast model predicts that we will sell 600 each for the next 4 months, if we do nothing else. The 600 will be disaggregated equally to 200 for each customer. And for some businesses, that may be perfectly acceptable. But what if you had this scenario? Do all three customers buy the same amount proportion each month? Does their sales history really look like this? Or does their sales history look more like this? Amazon is trending up. Walmart is constant and buys 66% of the demand. And other is trending down. So are you still sure that an equal distribution is okay? So back to our original problem. If we do nothing else, how would this disaggregate? I already said we didn't do anything. But we do need some sort of calculated value to initialize this data for a more accurate disaggregation. So now we have our what. What do we need to have happen? Specifically, let's agree we want to disaggregate that 600 based on the last 3-month average. Instead of this, we have this. But how should we do this? One option is what is commonly referred to as a proportional factor. Might have heard about this one already. It's a 3-step process. Step 1, calculate a proportional factor and store it somewhere. Step 1b, if it's easier to think in percentages, knock yourself out. Step 2, run a statistical forecast at an aggregated level. Step 3, if the target key figure, in this case statistical forecast quantity, is blank, then use the proportional factor you calculated back in step 1 to disaggregate. Anyone catch the critical word in that last slide? Here it is again. Step 3, if the key figure is blank, then use the proportional factor you calculated back in step 1 to disaggregate. Yeah, it's if. Calculating a proportional factor and storing it somewhere has one big problem. It only works if the key figure is totally blank. In the case of a statistical forecast, there are only 2 times it will ever be blank. That's ever as in ever in the entire time that product is being planned on IBP. Number 1, the first day or hour of go live, before the first forecast was run. 2, a new product. So not very often. Or another way of thinking about it, let's assume you wanted to recalculate the proportional factor based on the last 6 months average sales instead of 3 months. You might end up with something like this. But it doesn't matter, because you've already populated the statistical forecast quantity key figure. IBP will ignore these and use these. So think of using a proportional factor key figure to manage your disaggregation as a one-trick pony. The prop factor key figure can only be used one time. But a few slides back I implied that this was not the only option. Another better option is to recalculate the proportions directly. So instead of recalculating and updating the prop factor key figure that won't be used anyway 99% of the time, you just reproportion and update the statistical forecast key figure or any key figure directly. Back to our example. We are going to recalculate or reproportion or reinitialize this key figure. We still use our forecast model tool to calculate the 3-month or 6-month average, just like we used it to calculate the prop factor key figure. Only this time we update the statistical forecast key figure itself. Just remember to run your real statistical forecast model immediately afterwards. Otherwise, your sophisticated statistical model will just look like a 3 or 6-month average. So think of it less as using a proportional factor key figure, which is a how, and instead think of it as a reinitialization of the relevant key figure, in this case, statistical forecast quantity, directly. You are still accomplishing the same thing. And other benefits that you might not have realized. One, this can be done directly by a demand planning power user. No need to involve IT. Two, you can have different proportions for different products. Some products might have a 12-month average proportion, while others might need a 1-month average. Three, you can use product lifecycle inputs to help calculate these proportions. Phased out customers can automatically be excluded from the proportions. 4, different proportions for different key figures. 5, you can still use the prop factor key figure for those one-off key figures. For example, collab override or sales promos. Extra credit. Anyone else see an issue with this data example? If you recall, we were running the statistical forecast at the product location level and then making sure it was proportionally disaggregated. But was that really a smart thing to do? Look again. Amazon is going up 25 every month. But because we were using proportions to disaggregate, we ended up with a 3-month average in the future. If you ask a 6th grader what number comes after 150, 175, 200, they would have gotten it, all without exponential smoothing. It was worse for the other customer. Other is actually trending to 0. But we ended up with a forecast of 25 due to proportional disaggregation. There is a lesson warning here. If your proportional factor process becomes so complicated, you might want to ask yourselves if running the statistical model at a different level would be better. Here we ran the statistical model at the product location customer level, and we were able to better see the trends and generate a more accurate forecast. For more information on this topic, see multi-level statistical forecasting. Thanks for checking out Practical IBP on YouTube, and make sure you subscribe to stay up to date on the latest videos. You can click on any of the surrounding videos to learn more.